Dear students, I am Santa, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain about what is the drift velocity and what is the relation between drift velocity and current, or what is the relation between current and drift velocity. These two topics mostly discussed in this part video from the chapter of electric current in 10th standard level. What is the drift velocity and what is the necessity to discuss the drift velocity in the concept in the chapter of electric current or current electricity? What is the necessity means? In our previous video under the Lorentz group theory, I clearly explained to you, in every conducting material initially, some free electrons are there, nearly 10 power 28 electrons in a unit area. These free electrons are the responsible to carry the charge from one end to another end of the current, that is one end to another end of the conductor, that is called current passing through the conductor. But what we know that, initially we know that the electrons are in which motion? Random motion. Due to the random motion, one electron is collision with the another electron. Then what will be happen? They loses the energy. So due to the collision and also change the direction. We know that when you can take a ball, so the ball will be thrown towards the wall in one particular angle. When the ball is touches to the wall, it will be change the direction or not. Why? After the collision, what will be happen? Here two electrons are there. Two electrons are collision with each other. Their directions are changes. But due to the successive collision, what will be happen? They loses their energy. So due to the loss of the energy, their velocity is also becomes to zero. For example, initially the electron will be having certain velocity. It will be moving forward and due to the random motion, it is collision with the one electron. At that time, its energy will be losses. For example, simply I will be telling to you, if you are consider one electron, its initial energy is 100%. Initially, just you consider this one electron is due to the first collision. Just we can say that it loses the 10% energy. Like the same way, after 10th collision, what will be happen? Its energy will be becomes to zero. Why? For every collision, it will be losses the 10% of energy. After the 10th collision, what is its energy? Zero. If it does not have any energy, so it is able to move or not, it is not possible. That's why the initial velocity of the electron is zero. Means simply what we can say that due to the collision, finally the velocity of the electron is becomes to zero. That's why electrons cannot be moved from one end to another end. That is the one reason. And another one, according to the Lorentz group. So if you can consider a particular unit area of the cross section, the number of electrons move from left to right is equals to right to left. That's why so the resultant current is zero passing through a conductor. Now leave that one and we discussed here. Now we discussed about drift velocity concept. This it is a conductor P and Q. P and Q are the two ends of the conductor. In a conductor, so what are they? We know that electrons are there. Free electrons, maybe we can say that. You are consider one free electron. It is moving like this one, electron. So after collision with the anyone, then what will be happen? This one only we can consider. Okay. So the path is not like that one. It is a zigzag path. Maybe like this, for example, like this, like this, like this. So means here you are observing that. So you are consider the one electron, not only like this one, different paths are there. Okay. So anyway, if we are consider one electron, so due to this p electron will move in a conductor in their lattices, it will be collision with the other electron due to the random motion and change the direction and also losses the direction. Two will be happen simultaneously. So again, okay, it will be collide with another electron and change the direction and losses the energy. Then finally what will be happen? Okay, so the path of the electron is not follow the one particular path, it will be follow the zigzag that is depend upon the collision with the other electron. That's why when one electron will collision with the other electron, so due to the successive collisions the electron's direction is changes and as well as it losses the heat energy also. And finally, the energy of the electron is zero, is nothing but velocity is zero. That's why electrons is not move from one place to another place. But what we know that, so the rate of flow of electrons in a conductor is called current. Means electrons are moved from one end to another end of the conductor. Then you can say that current is flowing through that one. But here electron's velocity is zero. That's why what will be happen? No one electron cannot be moved from one end to another end. That is either P to Q or Q to P. Then what we can do here? So that's why, okay, we are connected to which one? A battery at the two ends. The free ends of a conductor is connected to the external source of, okay, is nothing but battery up to the opposite terminals at that time. Okay, here P end is connected to the positive terminal. That's why at the P end, which charge is created? Positive charge. Q end is connected to the negative terminal of your battery. Due to that one, at the Q end, negative charge is created. So this plus minus is nothing but plus is represented the higher potential, minus is represented the lower potential. We know that if any type of energy will be moved from one place to another place, it must be created some difference. One is the higher, another one is the lower. That's why it is the higher, it is the lower. Then at what will be happen? So this, okay, battery will be apply the, okay, some force on the electron because of the initial velocity of the electron will becomes to zero. Then what will be happen? So when they are connected, I said that okay, in our previous video, on the electron, two forces will be acting simultaneously. One is the repulsion, another one is the attraction. These two forces are acting in only one direction, that is towards the positive end from the negative end. That's why every electron present inside the conductor, means which electron, free electrons, they will be get the some force from this one and they will be moved in which direction? Forward direction. It's nothing but initial velocity of the electrons are zero, but after connecting to the external source is nothing but battery. The battery will give the electromotive force to the electron. Then the electron will be set into the motion and move with a certain velocity. That is called which velocity? Drift velocity. So initially electron velocity is zero due to the successive collision before connected to the battery. After connected to the battery, so then what will happen? So the electron will be again get the energy and move from one end to another end. Which end? Towards the positive end. So means so the electron will acquire the energy after create this one and moves towards the, okay, P end is nothing but positive end. That's why it is in the motion. When electron is in the motion, it has some energy or not. That energy we are called, okay, sorry, it has some velocity. That velocity we are called drift velocity. So listen very carefully. Simply, how to understand the drift velocity means, okay, the free electrons inside the conductor, due to their random motion, they collision with the other electrons in a particular unit area. So they loses the energy and change the direction and move into the zigzag path. Finally, its velocity is becomes to zero, so that no one electron cannot be moved from one end to another end. That's why current is not passing through a conductor when it is not connected to the any battery, because of the initial velocity of the electrons inside the conductor is zero. So the two ends of the conductor connected to the opposite terminals of a battery. So on the electrons, okay, two forces will be acting simultaneously, only one direction, that is towards the positive end. That's why, so the zero velocity of the electron will get the some force acting on it by the battery. It will be set into the motion towards the positive end with a certain velocity. That velocity of the electron we are called drift velocity. The velocity with which free electrons get drifted. Drifted means from zero to again set into the motion. The velocity with which free electrons get drifted towards the positive end of the conductor under the influence of externally applied source or charge. So listen very carefully. Force. So already it says that the velocity with which free electrons get drifted, which electrons, free electrons, okay, initial velocity is zero. That's why electrons cannot be moved further. But so what will be happen when the two ends of the conductor is connected to the external applied source, is nothing but battery. So the battery will be created the potential difference at the two ends. Then what will be happen? So it will be apply some force on the free electron. Then the free electrons get drifted, set into the motion with a particular velocity. That velocity is called drift velocity. The velocity with which free electrons get drifted towards the which end, positive end of the conductor under the influence of external applied force. That velocity is called drift velocity. It is denoted by the symbol of V of t. The relation between drift velocity and current, or current and drift velocity. It is important for 2 or 4 marks. What is the relation between drift velocity and current? So when we come to our topic, PQ is a conductor. The free ends of the conductor connecting to the opposite terminals of a battery. Then what will be happen when the free ends are connected to the opposite terminals of a battery? It created the potential difference. What is the potential difference? I will explain later. At the P end, so is connect P end, at the P end, positive charge is created due to the connected to the positive terminal, and at the Q end, negative charge is created due to the connection to the negative terminal of a battery. That is, you know that. Then what will be happen on the electrons? Some force will be acting on it. Then finally, every electron is set into the motion from Q end to P end. P is which side? Positive side. So drift velocity also I said that very clearly. The velocity with which free electrons get drifted towards the positive end or positive terminal, because of means positive end. Why positive end? So electrons are having the negative charge. Q end is also having the negative charge. Negative means like charges will be repelled, plus and minus. Unlike charges will be attracted. That's why every electron present in the conductor is repelled by the negative charge created at the Q end and attracted by the positive charge created at the P end. That's why every electron will be moved towards the P or positive end with a certain velocity. That velocity is called drift velocity. Anyway, now electrons are set into the motion means they cover certain distance or not. In every unit interval of time, during its motion, they cover certain distance. The distance covered by each is nothing but each single electron in a delta t time. Delta t is nothing but change in the time. Initially velocity of the electrons are 0, they are not set into the motion. After connecting to the battery, they set into the motion. So that's why when the experiment is started, for 0 to next 1 second, in 1 second it covers certain distance. In 2 seconds it covered some more distance. That's why time is changes, the distance covered by the body is also changes. That is the meaning of that one. Now in this one we write that so D is equals to V of D into T. Why? Because we know that V is equals to D by T. It is very clear. Velocity is equals to displacement by time or distance covered by a body in a particular direction only in the unit time. So here which velocity it is? Drift velocity, because of initial velocity of the electrons are 0, but they drifted after connecting to the external source. Then from this one, T transfer to this side. VdT is equals to T. Which T here? Delta T. We can say that because of which time? Delta T time. It is the for single electron. Next. The distance covered by the number of electrons, the distance covered by the number of electrons through a unit area. We know that very clearly. In our previous video I said that very clearly. In 10 power minus 6 meter square unit area, so nearly 10 power 28 free electrons are there, 8.5. That's why, what is the meaning of that one? So, only one electron is not moving at a time. In a small unit area also, 10 power 28 electrons will be set into the motion. Now here, we consider one unit area of the cross section, like this. It is the A. Through this unit area of the cross section A, so how many electrons are moving through that one? 3 electrons according to the diagram. Not not the 3, number of are there. So how many? 10 power 28 in the 10 power minus 6 meter square unit area only. That's why the distance covered by the number of electrons through the unit area. So then what we can write? D is equals to, okay, N is the number of electrons. Okay, so means N number of electrons through the which one? area. So VD delta T. Listen very carefully. The distance covered by the number of electrons through the unit area means, so D is equals to what you can write? N number of electrons passing through the area. So N not 10 power 28 in a small, but here this is not the 10 power minus 6 unit area. In this one, number of unit areas are there. 10 power minus 6 means small. For example, like this one. Okay. So in this unit area, okay, in this one also, okay, we can say that small unit areas we can say. Each unit area 10 power minus 6. Okay. So totally this area means, you know, that length into breadth. If this length and breadth is 1 meter square, sorry, 1 centimeter square, then what will be happen? Okay, this is called only one unit area. What is the one unit area? 1 centimeter square. So length is 1 meter, breadth is 1 meter. For example, what is the unit area? 1 centimeter square unit area. But here what is the one? 10 power minus 6 meter square. Okay, that is converted to centimeters. Anyway, leave it that one. So this is not the one unit area. So means, okay, it is the 1 centimeter square means 10 power minus 6 meter square. It is the smaller. That's why now this is we can cut into the two parts. This is for example 10 power minus 6. This is 10 power minus 6 meter square. Just we can check that in total. Here 10 power 28. Here is also how many are there? 10 power 28. So listen simply. In one unit area, single electron is not there. Leave that concept. Single electrons are not there. So nearly 10 power 28 electrons are there in small unit area. That's why N number of electrons. N is nothing but N. Okay, number of electron passing through this unit area. So this one. This is the distance covered by the number of electron through that area in a unit time. This is one. So, but instead of that one more thing is also you can find out that. What is that one means? Volume of electrons. Volume of electrons. Volume of, okay, conductor. So means the volume of conductor passing through the electron, or what is the volume of electron passing through a unit area. So that's why passing through a area. So we know that volume is equals to area into height. Okay. So but here this is the area we can say that. So we know that it is the length, it is the area. So this is we can say as the area. So this is we can say that means length into breadth into height concept we can say that. Okay. Now that's okay. That rod we can, that conductor we can slide this one. It is the unit area. So what will happen? It is the length, it is the breadth. This is the area. This is we can say as a h. That's why area. So area into height. That is nothing but what is that one? Volume. So here, but this vertical mode we can say where in horizontal mode. That's why this is V of D or D. Simply we can say that. So what I say that means okay. D is the distance, A is the area. That's why. So the distance traveled by the electrons through this one means volume of electrons passing through a unit area. So at that time, what is that one? A into H. Okay. H is nothing but here we can as a D. That is equals to A into D means all I say is that Vd into delta T. That is I already. Okay. Now the volume of single electron. This is one. Actually, what is that one? Volume of which one? Volume of each electron. Volume of each electron. Now volume of n number of electrons, because of number of electrons passing through the unit area at a time, not a single electron. That's why V is equals to NEA VD delta T, means n number of electrons. Okay, this is one. So here V is equals to delta Q. V is nothing but volume of the electrons. So delta Q is the charge. Why? Because of electrons are carry the which one? Q charge through that volume. So through this volume of the conductor, so electrons are moved from one end to another end at that time. Through entire the volume of the conductor, what are the electrons are there? That electrons are carry the which one? Q charge. That's why this volume of the electrons, the volume of the total electrons is equals to which one? Charge carried by the electron. Because of all the electrons, at a time they carry the charge from one end to another end. Now here, delta Q is equals to what you can write? NEA VD into delta T. Because of V is equals to delta Q. But we know that I is equals to Q by T. Current is equals to charge upon time. Now this one I will write. I is equals to delta Q upon delta T. Why? Because of initially electrons does not have any charge, but they carry the charge from one place to another place, means charge will be changed. So I is equals to delta Q means NEA VD delta T upon delta T. Delta T get cancelled. Then I is equals to NEA V of T. This is the relation between current and drift velocity. If the velocity of the drift velocity of electrons are increases, the flow of current is also increases. The drift velocity of the electrons are decreases, flow of current is also decreases. And this one NEA is transferred to the left hand side. Then V of D is equals to I upon NEA. So this is the formula or the relation between drift velocity and current. It is current and drift velocity same. So once again I will explain clearly for understanding of it. What type of matter we can write for this one, and what type of mathematical derivation we can write for this one. So I will explain neatly. So first what we can write here? We can write the for this one. If you can take selected any conductor, the free ends of the conductor connected to the opposite terminals of a battery, at that time it is created potential difference at the two ends. Then the electrons are drifted and move from negative end to positive end. That's why the electrons are covered certain distance. Then what you can find here? The distance covered by each single electron. So D is equals to V of D into delta T. I'll say that clearly. Next. The volume of each electron passing through a unit the volume of each electron passing through a unit area of conductor. V is equals to, okay, volume is constant because of the electrons number does not change. So that's why V is equals to what you can write, A into D, that is equals to A into VD delta T. Next here, okay. Volume for n number of electrons. So that's why V is equals to N E A V D delta T. N number of electrons passing through a unit area A. So this is covered by the distance. After that, okay, but V is equals to delta Q, and we know that V equals to delta Q, that is equals to NEA VD delta T, and we know that I is equals to delta Q upon delta T, that is equals to NEA VD delta T upon delta T. Both are get cancelled. So that's why I is equals to NEA VD and V of D is equals to I upon NEA. So this is the formula to find the relation between drift velocity and electrons.